learners, my name is Olumayowa Ogundipe. I teach biology. The topic we are going to discuss today is variation in population. By the end of the lesson, I expect the students to be able to define variation, list and explain types of variation, describe the causes of variation, and discuss the application of variation. What is population? Population is the total number of organisms of the same species living in a particular place and at a particular time. For example, let's say you are rearing goats and sheep, and you are asked to calculate the number of the goats and sheep. You can't calculate the goats and the sheep together. You have to calculate the sheep apart and the goats apart because they are not of the same species, though they are mammals. Variation. Variations are differences in traits or characteristics between individuals of the same species, which could be hereditary or acquired from the environment. Let's use human being as an example. Human being, we have certain characteristics. For instance, we have one head, 2 eyes, lips, 2 ears, and so on. But individuals can still be recognized because there are some differences in these traits. Say, for instance, look at the shape of the head, the shape of the eyes, the shape of the nose, and even the shape of the nostrils. All these are different. That is what is called variation. That is, all these differences in these characters possessed by the organism are known as variations. Variations can be divided into two. These are morphological variation and physiological variation. Morphological variation. Morphological variation means the appearance, the physical or noticeable appearance of individuals, of organisms of the same species. And this one now makes that organism to be known. For instance, in human beings, you talk about the colors of the parts of the body, like color of the skin, color of the hair, color of the eye, the height of the body, whether that person is short or tall, size and shape of the head, mouth, nose, ears, legs, and so on. Then the fingerprints. These are morphological variation in plants, in human beings. In plants, we have morphological variation. These are the height of plants. We have some plants that are tall, we have some that are short. Size and shape of the stem, the roots, the leaves, flower, fruits. Color of the flower, of the leaves, and also, when you look at the morphological variation, this noticeable appearance leads to what is known as continuous variation. This is because there is gradual transition between two extremes. Say, for instance, let's say in the class, you are asked to line up according to your height. You are going to start from the shortest to the tallest. You can see the gradual transition. If you are asked to line up according to your color, you can start from the darkest to the fairest. These are distinction, gradual transition. Because it has gradual transition, we say that the morphological variation leads to continuous variation. Physiological variation. Physiological variation is talking about what you use parts of your body for, organs in your body. Say, for instance, I can open my eyes, you can also open yours. I can close my eyes, you can also close yours. But sometimes, these organs, you can use it to perform a specific function. And another person, that function which you use it to perform, another person may not be able to perform that function. This is known as physiological variation. Physiological variation does not have any transition. It is discontinuous. Physiological variation leads to discontinuous variation. It is either you can perform that characteristics with the organ or not. Examples are in human being, ability to roll tongue. Look at me, I can roll my tongue. I want you also to roll your tongue. Yes, you can roll yours. You are looking at your brother. Your brother cannot roll his. That is what is known as morphological variation. Ability to close one eye and open the other. Look at me. I can close one eye and open the other. I want you to do that. No, don't use your fingers to close your eyes. Do it. You can see. You can't do it. That is, this is physiological variation. It's either you can do it or not. You can use part of the body to perform that function or not. Another one is ability to move the ears without moving the head. Look at me. I can't move my ears without moving my head. But some people can do that. It is discontinuous. It is either you can do it or not. Other example, we have differences in blood group. There are 4 major types of blood group. Blood groups A, B, AB, O. You either belong to one of these, not two, or more than that. Then ability to taste a chemical known as PTC. Some people, when they taste this chemical, it feels bitter. Some people, it is tasteless. That is, you are a taster or not taster. This is discontinuous. Physiological variation leads to discontinuous variation. Then, this variation in organism of the same species, what are the causes? You are a human being. You are able to recognize individuals, your friends. If you have about 100 friends, you'll be able to recognize them. And you are a human being. What are those causes of variation, these differences? These differences, the causes can be divided into 2. The genetic differences and the environmental influence. Genetic differences, these are the traits inherited from parents. For instance, you may inherit big nose from your dad, wide nostril from your mom. That is why you're able to recognize individuals at home. Take for instance, you have siblings at home, you are born of the same parents. That does not mean you will not recognize one another because of the traits that you have from your parents. Then, it can also be, this genetic difference can also be as a result of gene mutation. Gene mutation is as a result of sudden change in the chromosomes. The chromosome can be deleted or addition of chromosomes. For instance, in plants, a plant that is supposed to produce green fruits now producing yellow fruits. In human being, we have what is known as Down syndrome. A child with Down syndrome. That is genetic, that is gene mutation. Variation can also be as a result of environmental influence. That is, the environment, the surroundings can cause some changes in the traits of organism. Let us use plants as an example. A plant that is supposed to produce big fruits, now producing small fruits. It may be as a result of lack of essential nutrients in the soil, inadequate sunlight. All this one can later make the plant to become stunted. It will not grow very well, and the fruits that will be produced will be small. This is environmental influence. Also in human being, a person that is fair in complexion, now being exposed to too much sunlight, can become darker. This is environmental influence. Now, what I want you to know is that environmental influence cannot be transmitted from the parents to their offspring. It is only genetic difference, those ones that are located in the gene that can be transmitted from the parents to their offspring. Then, application of variation. What are the usefulness of this variation? It helps in crime detection. For instance, in a crime scene, to know the suspect, the object which the suspect touched can be looked at to get the fingerprints. Then, maybe the suspect had caught then, the blood group, that is, the blood sample of the suspect, can be taken to determine the blood group. Then, some witness can give this height, the color of the suspect by saying, I saw a man coming out from that room, from that house, he's tall, light in complexion. All this one can be used to get the suspect. It is also useful in blood transfusion. Like I told you, the blood groups are A, B, AB, and O. And if someone now needs blood, the person that needs blood is the recipient. The person that wants to donate the blood is the donor. Now, the blood group of the recipient must match that of the donor. For instance, let's say an accident victim needs blood, and that accident victim is having blood group A. That accident victim, blood that is going to be transfused into him must be blood group A or AB, blood group A, O, and not AB or B. If wrong blood is transfused into the recipient, it will lead to what is known as agglutination. What is agglutination? Agglutination is the process whereby the antibody present in the plasma of the recipient clots or clump the blood of the donor because they are not of the same blood group. And in the process of clotting it, you see block the blood vessels. And when this one now block the blood vessels, blood will not be able to flow very well in the recipient, and this one will lead to death. Let us now look at the donor-recipient compatibility in blood. The donor, A, is having blood group A, B, AB, O. Blood group A can donate to A. It cannot donate to B. It can donate to A, B because of the presence of this A here. A cannot donate to O. B can donate to A. B cannot donate to A. B can donate to B. B can donate to AB. B cannot donate to O. Blood group AB cannot donate to A, cannot donate to B, can donate to AB, cannot donate to O. O can donate to A, B, AB, and O. That is why blood group O is said to be universal donor. AB is universal recipient. It can receive blood from all the types of the blood groups. There's another thing we have to know in the blood group. When you are having blood group A, look at the genotypes. That blood group A can be homozygous for that A, that is the same blood group. Let's stop here. We are going on break. When we come back, we'll continue. Get ready your pen and your paper. Welcome back. We are discussing about the blood group and their related genotypes. A person with blood group A can be homozygous for blood group A. When that person is homozygous for group A, that means that person will be having AA. If the person is heterozygous for group A, it will be AO. That is, that O is recessive, while A is dominant. B If it is homozygous for B, it will be BB. If it is heterozygous for B, it will be BO. AB, that is codominance. O, that one is homozygous recessive, giving us OO. Then, another way by which variation is useful is detection of paternity. Two men are claiming to be the father of a child. Their blood group can be collected to know the real father of the child. And that is if those two men are having different blood group. But if they are having the same blood group, DNA patterns will have to be done to know the real father. Let us quickly look at this question on variation. A man whose blood group is heterozygous A is married to a woman whose blood group is AB, with the aid of genetic diagram, suggests the possible blood groups of their children. To do this, we are going to write a man. You must put X there to show that fission of gametes will take place. Then, the next step, the parental phenotype. The man is said to have blood group A. That is the phenotype. And the woman, blood group AB. Make sure you put that X. The next step, parental genotype. Parental genotype. From this, the man is said to be heterozygous A. What would that mean? Good. That is, it will now be AO, one dominant gene, A, and recessive gene. And the woman is AB. They are codominant. Both will show. Then, the next step, gametes. That means you are talking about the sperm and the ovum here. The sperm can only carry one allele. So also the ovum. Then you circle it to show the segregation of the gene. Let us now cross it. A fused with A, it will give us A. This A can also fuse with B to give us A, B. O can unite with A to give us A, O. It can also unite with B to give us B, O. You will write the dominant gene before you write the recessive gene. This one is F1 generation genotype. That is, when you are looking at this one now, we have blood group A, but that blood group A is AA. We have AB, we have AO and BO. Then the F1 generation phenotype. How? A, AB, we have A and B. That is, AA will give you A. AB will give you AB. AO will give you A. BO will give you B. That is, the possible blood groups of their children will be It's either A or AB or B. 3 types of blood group will be given. A, AB, or B. These are the possible blood groups of their children. Let's also do the next one. A woman with blood group A, heterozygous, claimed that her son, who has blood group O, was fathered by Mr. James, who has blood group A, homozygous. With the aid of a suitable genetic diagrams, A, prove or disprove the woman's claim. B, give reasons to support your answer. You start with the woman. And the man. Parental phenotype. The woman is said to be blood group A. The man, Mr. James, is also blood group A. The next step, parental genotype. The woman is heterozygous A. What would that be? Good, that is AO. And the man is homozygous A. Good, so dominant gene A. The next step, the gametes. You separate it to show the segregation of genes. Let us now cross it. A with A will give us A. A with the A of the father we give us A. The O with the A here will give us A. O. The O with the A will give us A. O. This is the F1 generation genotype. Let us look at the phenotype. F1 generation phenotype. AA, the blood group is A. AA is also A. AO, A. AO is A. That means the woman's claim is wrong, because when you look at this, the son is having blood group O. When you now look at this blood group, we only have A. That means the woman's claim is wrong. Mr. James is not the father of the child. Give reasons. These reasons, when you look at it genotypically, we are having homozygous A, 2 homozygous A, and 2 heterozygous A. All this gives us blood group A. That means the woman claim is wrong. With this, I hope you'll be able to define variation mention causes of variation, and I want you to answer this question, this assignment. I want you to answer it and submit it to our website. 1. Can a man with blood group AB possibly be the father of a boy whose blood group is B, given that the mother's blood group is O? Give reasons for your answer. 2. If the blood group of a woman is B and a child's blood group is AB, what are the possible blood types of the father of the child? Thank you. My name is Olumayowa Ogundipe.